It is indeed possible for a flame to act as a medium for an electric arc to conduct through. This phenomenon is known as a plasma arc. A plasma arc is a type of electrical discharge that occurs within a plasma. Plasma is a state of matter distinct from solid, liquid, and gas. Plasma is created when a gas is heated to a very high temperature. This intense heat causes the atoms within the gas to become ionized. Ionization is the process where atoms lose or gain electrons, resulting in a net electrical charge. The result is a gas composed of positively charged ions and negatively charged electrons. These charged particles are free to move around within the plasma. In a plasma arc, electric current flows through the plasma. The plasma is ionized by the intense heat generated by the arc itself. The plasma arc is characterized by its very high temperature, which can reach several thousand degrees Celsius. It also exhibits high electrical conductivity. In the described experiment, when an item combusts into flames, the flame effectively creates a plasma. This plasma provides a conductive path that allows the arc to continue conducting electricity. As long as the flame, and therefore the plasma, remains present, the arc will continue to flow through it. However, once the flame is extinguished, the plasma will rapidly cool down. As the plasma cools, the ionization decreases, and the arc will no longer be able to flow because the conductivity is reduced. Plasma arcs have a wide variety of practical applications. Firstly, they are extensively used in welding processes. Plasma arc welding offers precise and efficient joining of metal components. Secondly, plasma arcs are employed in cutting applications. Plasma cutting is capable of slicing through thick metal sheets with speed and accuracy. Thirdly, plasma arcs are utilized in lighting technologies. Certain types of lighting, such as plasma lamps, use plasma to generate light. Furthermore, plasma arcs are used in various areas of scientific research. An example is the study of nuclear fusion, which involves creating and controlling plasma at extremely high temperatures and pressures. In summary, the ability of a flame to conduct an electric arc is due to the formation of plasma. This plasma consists of ionized gas with free-moving charged particles, allowing electrical current to flow through it. The presence of the flame sustains the plasma, enabling the arc to continue. Understanding the properties and applications of plasma arcs is crucial in various industrial and scientific fields. Plasma arcs are not just a curiosity, they are a fundamental part of many technologies. The key properties of a plasma arc are high temperature and high electrical conductivity. The high temperature is what allows it to cut through many materials. The high electrical conductivity is what allows a current to flow. Now let's delve into some additional details about plasma arcs and their applications. The temperature of a plasma arc can vary depending on the specific application and the gases used to create the plasma. However, it is generally in the range of several thousand degrees Celsius, often exceeding 10,000 degrees Celsius. This extreme heat is what makes plasma arcs effective for cutting and welding materials. Different gases can be used to create plasma, each with its own unique properties. Common gases include argon, helium, nitrogen, and oxygen. The choice of gas depends on the specific application and the desired characteristics of the plasma arc. For example, argon is often used in welding because it is an inert gas that prevents oxidation of the metal being welded. The electrical conductivity of a plasma arc is also very high, typically several orders of magnitude greater than that of copper. This high conductivity is due to the presence of free electrons and ions in the plasma, which can easily carry electric current. The voltage required to sustain a plasma arc depends on the distance between the electrodes and the gas used. However, it is typically in the range of several hundred volts. The current flowing through a plasma arc can range from a few amps to several hundred amps, depending on the application. Plasma arcs can be used to cut a variety of materials, including metals, ceramics, and plastics. The cutting process involves directing a high-speed jet of plasma at the material, which melts and vaporizes the material in its path. Plasma cutting is often used to cut thick metal sheets because it is faster and more efficient than other cutting methods. Plasma arcs can also be used to weld a variety of materials, including metals, alloys, and dissimilar metals. The welding process involves using the heat of the plasma arc to melt the materials being joined together. Plasma arc welding is often used for critical applications where high-quality welds are required. In addition to cutting and welding, plasma arcs are also used in a variety of other applications, including surface treatment, material synthesis, and waste treatment. Surface treatment involves using a plasma arc to modify the surface properties of a material. For example, plasma nitriding can be used to harden the surface of steel. Material synthesis involves using a plasma arc to create new materials. For example, plasma spraying can be used to deposit a thin layer of a material onto a substrate. Waste treatment involves using a plasma arc to destroy hazardous waste. Plasma arc gasification can be used to convert waste into a clean burning fuel. The study of plasma arcs is an active area of research. Scientists are constantly working to improve the efficiency and performance of plasma arc technologies. Some of the research areas include developing new plasma gases, optimizing the design of plasma torches, and understanding the fundamental physics of plasma arcs. Plasma arcs are a versatile and powerful technology with a wide range of applications. They are used in industry, research, and medicine. As our understanding of plasma arcs grows, we can expect to see even more innovative applications of this technology in the future. The stability of a plasma arc is affected by several factors, including the gas flow rate, the electrical current, and the electrode geometry. Maintaining a stable plasma arc is crucial for many applications. For example, in plasma cutting, an unstable arc can result in poor cut quality. Various techniques can be used to stabilize a plasma arc, such as using a swirl gas flow or applying a magnetic field. The efficiency of a plasma arc is defined as the ratio of the power delivered to the workpiece to the power supplied to the plasma torch. Improving the efficiency of plasma arcs is an important goal because it can reduce energy consumption and operating costs. Various factors can affect the efficiency of a plasma arc, such as the gas type, the electrode geometry, and the operating parameters. The environmental impact of plasma arcs is also an important consideration. Plasma arcs can generate harmful emissions such as ozone and nitrogen oxides. However, these emissions can be reduced by using appropriate control technologies. Plasma arc torches are designed to generate and control plasma arcs. They typically consist of an electrode, a nozzle, and a gas supply. The electrode is made of a refractory material, such as tungsten or molybdenum, which can withstand the high temperatures of the plasma arc. The nozzle is used to constrict the plasma arc and to direct it at the workpiece. The gas supply provides the gas that is ionized to create the plasma. Plasma arc systems typically include a power supply, a gas supply, a control system, and a workpiece handling system. The power supply provides the electrical power needed to generate the plasma arc. The gas supply provides the gas that is ionized to create the plasma. The control system controls the operating parameters of the plasma arc, such as the current, voltage, and gas flow rate. The workpiece handling system positions the workpiece under the plasma arc. Plasma arcs can be used in a variety of industrial processes, including manufacturing, materials processing, and environmental remediation. In manufacturing, plasma arcs are used for cutting, welding, and surface treatment. In materials processing, plasma arcs are used for melting, refining, and synthesizing materials. In environmental remediation, plasma arcs are used for destroying hazardous waste and treating contaminated soil. The future of plasma arc technology is bright. Researchers are constantly developing new and improved plasma arc technologies. These technologies are expected to play an increasingly important role in a variety of industries. Safety considerations are paramount when working with plasma arcs. High voltages and currents are involved, and there is a risk of electric shock, burns, and exposure to harmful radiation and gases. Proper safety equipment, such as gloves, eye protection, and respirators, should always be worn. It is also important to follow all safety procedures and to be aware of the potential hazards. Plasma arcs can generate electromagnetic interference, which can disrupt the operation of electronic equipment. It is important to take steps to minimize electromagnetic interference, such as shielding the plasma arc equipment and using filters on the power lines. Plasma arcs can also generate noise, which can be a nuisance to workers and nearby residents. It is important to take steps to minimize noise pollution, such as enclosing the plasma arc equipment and using noise barriers. The cost of plasma arc equipment can vary depending on the size and complexity of the system. However, plasma arc equipment is generally more expensive than other types of equipment, such as oxy-fuel cutting equipment. The operating costs of plasma arc equipment can also be significant due to the cost of electricity, gas, and consumables. However, plasma arc equipment can be more cost-effective than other types of equipment in some applications due to its higher speed and efficiency. Plasma arcs are a complex and fascinating phenomenon with a wide range of applications. Understanding the principles of plasma arcs is essential for anyone working with this technology. With proper training and safety precautions, plasma arcs can be used safely and effectively in a variety of industries. Plasma arcs are a powerful tool that can be used to solve a variety of problems. As our understanding of plasma arcs grows, we can expect to see even more innovative applications of this technology in the future. Remember that proper safety precautions should always be taken when working with high voltage equipment. The explanation provided here is for educational purposes and should not be taken as professional advice. Always consult with a qualified professional before working with high voltage equipment.